All right, and we're live. Welcome, everybody. Welcome, Sören. Thank you for doing this. So we'll wait a couple of seconds to let everyone roll in. So feel free to say hello in the chat. Tell us where you're joining from. In the meantime, I'll cover the usual housekeeping rules. So the session is recorded. So, don't go crazy in note taking. We'll share this tomorrow in an email to everybody alongside, useful resources. Hey, Rabia, useful resources that Sören will cover, anything, useful links, whatever. We'll send all of that stuff over. So don't worry about that. Great to see people using the chat. Most of you are sending to hosts and panelists. So if you use the chat, make sure that you're sending to everyone so that everyone can see. Also, if you have questions, you can use the chat, you can use the Q&A. The Q&A is preferred because then that way we can actually queue your questions and people can upvote them and so on. So yeah, thank you, Claes. That's a good correction. Okay, sweet. I think we're already a couple minutes in, so we can get started. Sören, over to you. Should I launch the poll that you prepared already?
Let's start the poll in 2 minutes. I'd like to introduce myself.
You let me know when.
Beforehand.
I'll shut up.
Super. So, hello everyone. Nice to meet you. I'm Sören. Luca, thank you so much for giving me the opportunity to speak to the audience today. In today's session, I would like to share with you some learnings that we gained by looking at hundreds of IaC setups and mostly hyper-scaling companies, startups, etc. So who am I? As said, my name is Sören. I'm one of the founders and CEO of Mineros. Please find some links here to follow me on LinkedIn or Twitter after that talk if you're interested in diving into specific details. What is Mineros? So we are a bootstrap company out of Berlin, Germany, and we basically specialize in providing pre-configured, documented, and tested infrastructure as code blueprints that enable engineers to get up and running on public clouds in no time. And we focus on implementations and solutions for Google Cloud, AWS, Kubernetes, GitHub, and a few other. So how do we do that? Basically, the products that we provide are landing zones, again, for Google Cloud and AWS, infrastructure service catalogs, and then a product that we've recently built is called GitHub as Code, which is basically shifting the management of the GitHub organization from the GUI to infrastructure as code with a certain abstraction layer that I will elaborate on in a little bit. We work for companies mostly based in Europe, such as Flink, Scalpy, Suped, Inform, Klang. So a clear focus on e-commerce, instant grocery delivery, gaming, and companies that operate on data. So today's agenda, what would I like to discuss with you guys and basically share some learnings on? So a quick introduction to infrastructure as code, and then how we scale Terraform, patterns that we use by working with customers, and some insights on processes and team setups. But let's start this talk with a question, and that would be, how many of you have worked with Terraform before? So I get a brief understanding of the audience that I'm talking to.
All right, poll launched.
Yeah, let's give
see
it a
if
minute.
We can get in triple digit. We're in triple digit, so statistically relevant. I'll end it and share the results here so you can see them.
Perfect. Okay, so that's great because the introduction to infrastructure as code in Terraform is a small part of this presentation. I hope that I don't bore you with that too much. So what is infrastructure as code? infrastructure as code basically allows you to manage infrastructure through configuration files rather than through using GUIs, right? And it enables you to build change and manage infrastructure in a safe, consistent, and repeatable way by defining resource configuration that you can version, reuse, and share. The various technology provider out there, cloud agnostic vendors such as Terraform and Pulumi, and then there are also cloud specific vendors such as CDK, CloudFormation, etc. We as a company tend to focus on Terraform because from our point of view, it's the most mature technology in the market. And we also like to extend the usage of Terraform among multiple providers. So not only cloud environments, but we basically manage stuff such as GitHub, Cloudflare, Datadog, Secrets, Vault, whatnot. So how have you been managing the cloud in the old ways? ClickOps basically, right? Or some older technologies, but what's the downside of ClickOps? Why do we really want to use infrastructure as code? So basically it's slow. It takes a long time to figure things out. A lot of try and error. Been experienced this personally for many, many years. This little to no reusage of the things that you implement and that you do, right? There's also a little knowledge transfer. So quite often we see people that have, this God mode status that do kind of everything, centralized knowledge silo, and then there's zero to little knowledge sharing. There's also no versioning. So you don't really have an audit trail, a part of what the clouds or the providers are offering you. There's no ability to roll back changes, and there's also no version history. And it's, of course, error prone, right? There's no reviewing process. You can't leverage automation in order to validate what you want to deploy before you deploy it. And what I've noticed most often is that environments just diverge over time. So why are we using IaC? Important to mention, IaC is merely a set of technologies that help you solving those problems, but of course it introduces other problems that you need to solve along the way. So basically it enables us to, for fast execution, because instead of you deploying changes, machines should take over the jobs, aka CI/CD. It's reusable. We can reuse the code among several environments. We enhance and improve it over time. And then we can, of course, also build on top of existing code pieces, modules, etc. It's usually well documented. So I tend to think in a way that well-written code acts as documentation itself. Some people don't agree with that, but for me, it highly depends on the quality of the code. And then, of course, you should add comprehensive additional docs. We bring it to some extent that we even generate documentation for the things that we are doing based on annotation and variable documentation. It's versioned, so you basically have a full history of changes, easy rollbacks. Of course, that requires you to write comprehensive Git commits, structure your changes properly. Maybe use things such as convention commits, which I'm a big fan of personally. And it's just way more reliable, right? You can leverage static code analysis, ensure integrity through automated tests, and then of course the most basic form of tests, which are code reviews. So what is Terraform? Certainly on the peaking in its hype curve, I would say. Terraform is basically one infrastructure as code tool, and it enables you to define cloud, on-prem infrastructure, again, also other SaaS providers and vendors in a human-readable, declarative configuration language, which is called HCL, HashiCorp configuration language that you can virtually reuse and share, right? And it does so by providing you with a consistent workflow to basically manage and provision all of your infrastructure throughout this life cycle. So this is a literally copied statement from Terraform.io. That's why I put the source in the footer. Okay, so some learnings that I would like to share when working with Terraform on scale, especially when moving from, a single person that is working with Terraform in your company, or two persons that are working in your company with Terraform, to multiple teams, multiple environments, many repositories. So first of all, what's the problem with the growing Terraform code base? Most likely, you end up having long execution times, right? Your CI/CD pipelines would need to download all the dependencies. They maybe would run some integrity checks, and by the end of the day, when using Terraform, there's this phase that Terraform looks at your current configuration, the state of your configuration, and it compares it with whatever is deployed in the cloud. So that means as more resources you're managing with Terraform, the time consumed for this workflow scales linearly, right? So by nature, what I see most of the companies doing that want to handle Terraform on scale is to think how they can split up their Terraform code and state into isolated units. So what's helping here is to come up with a modular structure, right? So to just elaborate on that, Terraform Modules is basically a pattern that allows you to structure related resources in a reusable, and isolated modules, right? But modules on their own don't really help you to solve the previously mentioned problems, as they don't run in isolation. They don't really have a state. They don't have this. They don't live this life cycle, right? So as long as you keep a centralized state for your Terraform code, all modules used in this code will always be planned and applied. So it's a matter of structuring your code, but it does not really help you preventing long runtimes. So this is why in the Terraform community a couple of years ago, there was this concept of stacks introduced, and I believe the first team to do so was the team behind Terragrant, which I also will elaborate on in a minute. They did a lot of good to the industry, published a lot of good content, also educational content, and basically looked at Terraform also in its early days and what problems to solve. So what is a stack? A stack is basically a runnable Terraform module that operates on a subset of resources. It has its own state, and it also mostly has its own provider configuration. So when do you want to think about introducing stacks? The way that we like to look at it is that a lot of companies that are in the early stages, even pre-product market fit, it doesn't really matter so much, right? What matters is that you have a relatively quick go-to-market, and quite often you may not even want to use the cloud, or you may not even want to use infrastructure as code because it just adds too much overhead for the value added. But in a later stage of the company's life cycle, as the code grows, it certainly becomes hard to manage, right? As mentioned, CI runtimes may take forever. And then the point that I tend to look at is like, once you can't really map code onto different business units anymore, it's a good time to think about introducing stacks. So we released a tool a couple of months ago. It's not the only one in the industry, so I'll share other solutions in a minute. But basically, TerraMate, check it out. It's open source on GitHub and our GitHub organization. It's code as a tool that helps you to keep your code dry. It's basically a code generator for Terraform. It helps you to detect changes on stacks, modules. You can natively execute any Terraform command. It comes with execution order, force execution, and it's all configured and written in pure HCL. So it's not a wrapper, actually, it's a code generator. And the point of talking about stacks is that you basically want to split up your monolithic code base into several stack hierarchies that represent business units. And what you can see here on the right is an example of a landing zone implementation for Google Cloud. So in Google Cloud, you have resource entities such as projects, which are really the lowest level resource in the organizational structure. In Google Cloud, they enable you to bundle certain resources, IAM, billing, etc., in an isolated manner. So the way that we tend to look at this is we look at those higher level business units inside of a landing zone, which would be projects, folders, IAM configuration, custom roles, and even each custom role could be its own substack in a higher order stack. So this is kind of the way that we tend to look at it, and to also kind of provide engineers with the mindset that they should really have a business-centric thinking. So what's dry? Don't repeat yourself. Basically, it's a software engineering principle that aims to reduce software complexity. Quite often when writing software, any piece of information that is duplicated among your code base is liable to get stale and cause problem. It also increases your maintenance effort. It needs to be updated in multiple locations, and it may increase cost and difficulty to maintain software. So basically, do not repeat yourself. Dry is a methodology that provides you with an easy way to update and access single representation of information and use it in multiple different environments and multiple occurrences. So how do we do that with Terramate? How do we think dry in terms of Terraform? And that's a little bit different than what's been done in the past. So we highly leverage modules in a sense that as a company, we publish a lot of open source modules, so-called base modules that basically take care of single resources or set of group resources. So typically a resources and its IAM definition. And then we basically leverage code generation, not only modules, but also code generation to reduce the amount of repetitive code. And the way that it works with Terramate, just want to quickly elaborate on this, is that this is generated HCL statement that we can basically, you don't need to do so, but you can give it a condition. So in that specific example, we basically say, hey, the code defined in the content block will be generated for every stack that occurs in the folder subdirectory, right? And then there's another concept called globals, which is basically sharing of data exposed through configuration. So in simple words, what we aim to do here is to get rid of dependencies as much as possible, only define them once, and then manage all the shared data, whether it's certain versions of a model that you use or attributes through globals. And if you're interested in learning how we do this with Terramate, we provide comprehensive examples and learning material in the repository or by reading our articles in blog.mineros.io. Also, again, feel free to ping me after this talk if you want to have a one-to-one session or even talk to this team and challenge certain problems. There are other vendors in the ecosystem that are aiming to solve the same or similar problems. So two solutions that we've used exhaustively is TerraGrant and TerraSpace. The reason why we came up with Terraform is really to also have a native way of doing that, right? So Terraform generates native HTML code, it runs in the Terraform cloud and all the other third-party vendors without, having the requirement for integrations. Tests. So we tend to look at different layers of tests. Basically, we try to cluster those in code reviews, static code analysis, and automated tests. And code reviews is really just the first guardrail that you should always, when handling infrastructure, provide a plan before actually executing and apply in your pull request to give the teams the visibility and the accessibility to information of what's happening in the underlying CI run, right? So a very basic way of doing that would be to provide, just an extract of the plan, as you can see here in the screenshot. A more comprehensive example would be to generate based on the plan file to generate some kind of diagram, right? That is more accessible for people that don't speak Terraform. Static code analysis is basically helping you to detect and prevent misconfigurations, vulnerabilities, threats, such as exposed secrets. A various set of tools exist. TF-lint is great for linting your code base. And then on the security side of things, we have Checkov, TF-sec, and Fugitive Regular, which is my personally preferred vendor in that space. And all of those vendors also have a commercial offering, right? If you don't want to configure this yourself, if you don't want to maintain this yourself, there are SaaS solutions available. And then we also usually recommend engineering teams to use pre-commit hooks. So basically things such as Terraform format, Terraform validate, and TF-lint. And why is that? Because you can basically detect misconfigurations before they even hit the repository, right? And that basically saves you build minutes, right? You should not really open API before you validated that whatever is sane and secure, and before you validated your changes are actually, you ensured integrity in a way that they are linted, sane and secure. Anton Bibenko, the maintainer of the AWS modules, he came up with this brilliant idea to save this organization's name early in the days, and he's doing quite a lot of good things for the community. So he's one of the publishers of, I think, the mostly used AWS Terraform modules in that space. So here's that. He owns that pre-commit Terraform repository, which is a very comprehensive list of ready-to-use pre-commit hooks. And then from our side, we also add some hooks for Terraform and Terramate that may be interesting for you. By the end of the day, you most likely come up with your own implementation with your company based on your requirements. You just fork something, modify it and use it in your own ways. Automated tests. So the way that we are thinking about testing is basically unit tests and then integrity or end-to-end tests. Whereas in unit tests, we don't really deploy underlying infrastructure. We want, or we kind of focus on testing outputs of Terraform plans for correctness, so that we can validate whatever logic we implement when using different resources in a module. The outputs are expected to match the inputs, right? And this is because the sake of speed basically. End-to-end tests, we mostly use those throughout our solutions, or throughout implementations. Basically, an implementation in our sense is something that integrates a lot of different resources or modules. And there we deploy real infrastructure. So for example, a Kubernetes cluster on, an EKS cluster, GKE cluster on AWS or Google Cloud, doesn't matter. We create a namespace, maybe, attach some RBAC roles, whatnot. deploy a service and validate if a certain endpoint is reachable. This would take a lot of time, depending on the complexity of the underlying infrastructure. And this will also cost you money as you deploy real infrastructure. And then there are like edge cases to consider, such as like sometimes the deployed infrastructure based on the outcome of the test cannot be cleaned up. So you need to have some kind of, automated processes and observability of maintaining your cloud environments and cleaning those up. Yeah. So the way that we do those is basically not on every single commit. Unit tests we run on every single commit to the repositories. Integration tests most likely based on a manual workflow trigger, right? There are also great solutions provider in that space that basically help you to work on the previous mentioned point. So for example, on the CI and CD side of things, there's Terraform Cloud, Spacelift, Scala, and Zero. They will help you to reduce your go-to-market and rapidly reduce your spend on maintaining custom solutions. Personally, the best experience I've had so far was with Spacelift. Those guys are also supporting more tools than Terraform, right? So different IaC tools. Branching. So we think that using branches for managing environments in IaC doesn't really scale. So the workflows that we implement, main always represents the single source of truth. And we most likely have the whole infrastructure hierarchy represented in one single code basis. There might be some cases where Terraform workspaces may make sense, but by the end of the day, based on what I've seen or based on what we've seen, it's just way easier to navigate and iterate through code bases, whereas the code base represents all environments. So it's also easier to use different backends, multiple backends, different versions. It's easier to share data and enables for concurrency. A learning that we kind of learned the hard way is to always pin exact versions when it comes to modules and providers. So I see a lot of companies not doing that. They would use a range of version, and then the reality is that most of the maintainers and contributors behind providers or modules out there don't really follow strict SAM versioning. So they may introduce breaking changes even within the change of a minor or patch version, which can eventually cause your infrastructure to fail, right? Even worse, it may cause things to be destroyed. So the way that we think about it is that you should always exactly pinpoint a certain version and just ensure integrity, right? By the end of the day, infrastructure is something living and breathing, and most likely damages occurring in infrastructure are fatal. What you can think about is automatically update minor versions of modules and providers. It's a little bit controversial what I said before, but the way that we think about it is that if you have an environment where you ensure integrity through tests and you ensure rollouts through automation, that may be possible. Yeah. So now we only did that with minor versions so far. I know that there are solutions providers out there that they try to automate this throughout all versionings, but by the end of the day, again, the risk added when managing infrastructure and automated handling of dependencies, in my opinion, is just not worth it. Okay, let's come to patterns. So here I would really like to talk about two things, landing zone and service catalog. So what's the goal behind enabling a pattern? It's basically to enable developer self-service. Developer self-service for me means like figure out a way of enabling your delivery teams to self-service, whatever kind of infrastructure they need, because otherwise you need to linearly scale your ops, DevOps, cloud, however you name it, teams, with the amount of developers in your organization. And this you most likely do by providing easy to use APIs for creating environments, infrastructure, etc. So how have this been done traditionally? Moneytech is talking about this a lot. Typically, in a rather traditional environment, developers would go through a centralized ops team, create some kind of Jira ticket. Ops is always working at a limit, it's always pressured, so it may take them 2 weeks. And then ideally you wait another 2 to 4 weeks until a database is provided and you get access to the secrets, etc. In reality, it most often looks like this. So there's this constant, going forward and backward of feedback loops and question being asked. And it's just a lot of time wasted along the way. So what we are trying to do always is to kind of, look at platform engineering methodologies. So depending on the size of the organization, providing developer portals that are just nothing else than clients on the top of a bunch of APIs. We create GitHub repositories, services based on service templates, Kubernetes namespaces, supporting observability tools, CI/CD, and then finally the rollout to different environments for you. And we do this by building everything on top of infrastructure as code. So even the GitHub management or the observability management is usually managed with IaC, with the difference that now if a developer uses an API to request those resources, they don't need to open a pull request in 12 different repositories. It's really just an automation committing to those repositories, ensuring that changes get rolled out, etc. Landing zones. Landing zones are an interesting concept when deploying infrastructure in the cloud. It's basically a foundation of your platform, and it takes care of resource organization, billing, policy management, networking, and identity and access management. And the idea is that you basically provide a basic framework for end users to consume, so they can self-service deploy environments that are pre-configured in line, with security policies and compliance guidelines according to your company's requirement. So why is this important? We want to enable for faster delivery and self-service. So you really want to centralize this and manage this with IaC, Terraform, to enable teams to self-service provision environments, to enable maximum security and compliance. Least privilege principle is something that we look at often. And that does not only mean that we limit privileges and permissions for individuals, but also for things such as service accounts, for example. So if you create a landing zone that maintains multiple accounts in AWS or multiple projects in Google Cloud, really think about creating individual service accounts or IAM users that manage those accounts and projects, and really just apply the permissions needed in order to manage those environments. And then by the end of the day, also efficient on and offboarding. So fast and efficient onboarding, basic teams, individuals, and then of course machine users. Landing zones also help you to prevent vulnerabilities in the limited blast radius. This is because you can basically use security posture management in a centralized manner, and things such as policies, IAM policies, etc., to prevent users of spending too much money. And they also help you to reduce costs. So basically, they centralize cost monitoring and budget management, and restrict developers of how much they can spend in sandbox environments. So landing zones are really something that, especially with Terraform, there are a lot of guidelines out there, a lot of different approaches, and this is something that when handling infrastructure on scale, you really want to take care to basically take off this complexity of the developers. We also think that sandbox environments are quite important. In my opinion, developers, and I will come to this in a little bit, should have access to sandbox environment for testing and learning purposes, even without adapting IaC. So if you just want to, test PubSub in Google Cloud to see whether this is a usable queue for your service, then you should perfectly do this without having the complexity of defining this as code. Of course, here it's important to restrict costs, automate cleanups, and have the observabilities and alerts in place, so you can see if things get out of whack. Service catalogs. Terraform is also pretty good technology for basically defining reusable patterns for deploying services. So service catalog is basically a company or team-specific catalog that enables your engineering teams to deploy services, including backing infrastructure. So this might be a service on Kubernetes, that a deployment on Kubernetes that requires a database in the cache that is deployed on AWS, Google Cloud, or even multi-cloud, of course. Those are usually defined as code. You design those for production use, and then again, they should really meet company requirements, scalability, high availability, and compliance, and of course be tested. And the idea of a service catalog is to abstract the complexity away for developers so that they have an easy to use API. How do we do that as a company? How do we think about this? So just quickly checking the time. Okay, so it's still good. So typically we build a service catalog by building on top of various base modules that are usually provided by open source vendors. There are a lot of open source vendors in the Terraform space. You can just check registry.terraform.io to basically see the different providers and modules. And so we bundle those into very opinionated service catalogs that are most likely maintained by your centralized platform or cloud team. And then in order to make those accessible for developers, we may just add an abstraction layer on top. So developers like to use YAML. Terraform is not really a developer-centric tool. It's more an ops-centric tool. And we'll get to this in a minute as well. So once you operate on scale and you realize that everyone is complaining about the complexity of handling Terraform, just think about what could be the right abstraction layer. It could be a custom solution in-house, some translation from YAML to Terraform, or you simply use SaaS vendors such as Space and provide you with tab service. And then also whenever you think about handling IaC, the story really doesn't end with the cloud infrastructure, right? You can manage a lot of different vendors with IaC. GitHub is one example. Observability providers such as Datadog and DNS, for example, Cloudflare. So start, shifting repeatable pattern from managing things manually to infrastructure as code. Because to remind us again, what we always want to consider and enable is having consistent workflows that can be automated without having to use GUIs. So the point here is to shift the ownership of running services to the service teams. You as platform DevOps cloud engineers should really just be an enabler, not a gatekeeper. It's all about developer enablement. And then to sum up, Terraform is really just a technology. And what I say is, hey, think in terms of workflows instead of technologies, right? It doesn't really matter much whether you use Terraform or Pulumi or what else, something else. A part of course, the majority of the tools in the ecosystem and your own experience, your preferences in the companies. But what's more important is that you really think in terms of enabling your customers, your users, your developers. Then as your company grows, and it's something we see quite often. So Flink, this a customer of ours that I mentioned early on in this talk, as they grow to a certain extent, they just started spinning out to a heterogeneous environment. So most likely you will end up managing patterns such as the landing zone, service catalog, or the landing zone is Terraform, because this is very ops-centric. Your ops teams, they will love Terraform, but then the different business domains in your company, for example, data is most likely wants to use something different than the engineer. So you will end up working with multiple tools. You will end up working with a heterogeneous set of tools that they solve different problems and they address different personas. So your responsibility is really to make sure that those teams can use those technologies in a safe, sane, and effective manner. That's it from my side for today. So we almost talked 45 minutes. I think, I hope it was enough time to elaborate on the certain topics and enable us how we tend to think about it. Feel free to ask questions now. Happy to dive into the details, and then always don't hesitate reaching out to me after the talk if you would like to discuss something in detail as well.
Awesome. Thanks, Sören. And we already have a bunch of questions. I'll actually do something a little bit different. Start reading out, because we have a couple of questions on the YouTube stream as well. So I wanted to tie this in. So Netman 013 asking, so for the pros, how can you orchestrate multiple Terraform states and multiple Terraform runs when they depend on each other? So for instance, when you have separate infrastructure and Kubernetes cluster services.
Yeah, so this depends on the tool that you're using. In Terraform, for example, there's the concept of depends on, where you can basically create a dependency tree by explicitly setting dependencies, or by using outputs of one module into another. Okay. In Terramate, the way that we think about it is basically we have to we have directives such as before, after, and then there's soon to be one that is called once, in order to also manually always trigger the run of a certain stack, although there are no changes. And we don't really use output of stacks, as it just causes the tightly coupled dependencies. So, and also sometimes the name or the ID of the bucket may not be, just as an example, may not be available immediately. So the way that we tend to think about is by sharing data among certain stacks. Now, you can use remote state calls, for example, to also go through to also cause stack dependencies. Yeah, by basically searching data in the state of one stack and using it into another. Yeah, again, this is really tool specific, and also the certain SaaS vendors that are out there, and they also have their own methodology. So it depends. Hope that answered the question.
I think so. Sorry, not again. Asking why should I choose to use Terramate over Terragrunt? Daniel actually replied with a blog post from your blog, but maybe you wanted to share a couple of thoughts on that.
So why would you like to use Terramate over Terragrunt? Yeah, again, Terragrunt is a great tool. I used it for many years myself, and I did a lot of good to the industry. But the fundamental difference is really that Terramate is not a wrapper, right? Whenever you use Terragrunt, you basically end up in an environment where you are Terragrunt dependent, right? You write Terragrunt syntax, and now you end up having a code base that cannot be executed natively by Terraform anymore, right? Whether what we do with Terramate is not a wrapper. Terramate is a code generator. So whenever you use Terramate, you end up generating a bunch of native Terraform code, and you can execute it in all kinds of third-party vendors without having the dependencies installed. Also, we add a few capabilities that are not available in Terraform out of the box. For example, change detection. Yeah. So we offer a way that you can basically detect based on your commit history what has changed, and just execute those stacks. Hope that helps.
Interesting. Yeah. All right, I'll go for the most upvoted ones. So Cheryl, could you expand more on the concept of landing zones? Perhaps an example would help illustrate. My team promotes a self-service model within our company, and we're interested in making this process easier and more refined.
Okay, so I don't have a graphical representation at hand that I can share right now. But the idea of a landing zone in cloud is basically to centralize the management of the foundational services of your cloud. So what are the foundational services of your cloud? Everything that you basically don't necessarily need to deploy infrastructure. So that might be IAM, yeah. That might be a project or account vendoring machine or factory, yeah. So for example, if you work in a multi-project or a multi-account environment, you want to enable teams to deploy the services and infrastructure in isolated environments, right? This is why you have accounts in AWS and projects in Google Cloud. And what a landing zone is basically doing for you, it streamlines those settings. Again, billing, IAM, policies, yeah, restrictions when it comes to cost and security and threats, in a centralized manner. So if you would not have a landing zone, you would need to configure, every single project when it comes to what kind of billing is it using, how to create a service account that is rolling out infrastructure as code changes in this environment, etc. And a landing zone is basically the key enabler for you to centralize this and to abstract the complexity of the development teams.
Got it. Let's see what we have here. So another one I think was interesting was Sheer. What do you think of Kubernetes native IaC tools such as Crossplane?
They're great. They're really, really great. So we recently, Crossplane, I think it's on its rise. We recently used a Google config connector a lot in a certain project, which basically also enables you to deploy a service-depending infrastructure through Kubernetes operators. For deploying and managing backing infrastructure, it's a great way of doing so. It kind of needs a different mental model as it's an asynchronous process most of the time, whereas Terraform is a synchronous process, right? It's a blocking process. So, but I would like to come up with a clear separation between, for example, landing zones are not a suitable concept for that. Whereas when managing backing infrastructure for services, and this might be overseeable, right? You might need a few databases or a few different types of databases, a few different types of caches and queues for your services to run, but you typically don't deploy whole cloud environments in a sense that you manage complex billing, IAM, or whatnot with those, right? So for service catalogs, certainly good solution. And again, you most likely end up in an heterogeneous environment over time anyways. For centralized management, such as landing zones, not suitable in my opinion. Hope that helps.
How do landing zones work as a practical matter beyond concepts and advantages?
How do landing zones work in a practical manner? So basically, I believe I elaborated on this in my previous answer a little bit, but again, landing zones a kind of a centralized foundational layer of your cloud that you take the hard problems of the delivery teams, manage and solve those by your centralized platform, cloud, DevOps team, or whatnot. But by the end of the day, a landing zone is also something that evolves over time, right? So you might end up with something very, very lean, such as an account vending machine. Yeah, just enable developers to create new accounts on the fly as they want to deploy new services, right? So they can do this in an isolated manner. And then you extend and elaborate on this over time. So over time, this is what I said, you may add things such as Datadog dashboards, right? Or Datadog child organizations, Cloudflare DNS management, etc. This is very company and requirement specific. So typically you treat it as an internal product, right? You create a roadmap, and the way that we start working and iterating on this is always by basically looking at added business value versus complexity, and then focus on the 20% of the roadmap that is easily executable and provides a lot of value. So treat it as an internal product. Sorry, hope that helps.
I guess one of the $1 million questions when it comes to IaC. So what do you use to identify infrastructure drift? For example, resources that have been created outside your code.
Yeah, that's a good question. Actually, I should have elaborated on this in my talk, I guess. So different kind of solutions. Now, what we basically do with most of the customers that we are working with is that we are discovering and detecting those drifts in the sense of that are automated pipelines running, as scheduled jobs. And they would basically, depending on the underlying process that you work with, either notify you through Slack alerts or even create, for example, tickets. Yeah? You can bring this to an extent that you partially, for example, resolve them in an automated manner. I haven't really seen this working on scale, so I would like, if someone could share learnings with me after that talk and I learned something as well, would be great. But there's certain vendors, such as Fireflies, for example, working on this as well. Yeah. But I guess the most important part is to detect those and to bring awareness to the team, because drifts will occur frequently, especially in IA.
All right. So Klaus is saying, I've worked as a consultant using Terraform for 3+ years. I've seen monorepos utilizing stacks in dependent states, and currently the company I'm working for has a repo for each stack. What are your experiences and preferred way of structuring stacks?
Right. So depends on how you see stacks. I would say a monorepo does not prevent you from using different stacks. Okay, so first of all, you should never split or fan out into several repositories in the first place, right? Because it adds complexity by, for example, centralizing pipeline management. Yeah, if you use something like GitHub Actions, you want to have reusable GitHub Actions that are provided and maintained by centralized teams. Yeah, compared to just using SaaS vendors. But the complexity of managing a monorepository versus managing multiple repositories, it's just easier to manage a monorepository in the first place. So I've seen the use case, in my opinion, occurs when you start fanning out into different technologies. Other than that, I've seen thousands of cloud stacks being managed in monorepositories, and then it's more in a matter of how you split up your estate into several stacks. Yeah? And there, a recommendation from my side is, hey, if you have a code basis that, for example, has a 20-minute CI runtime or longer, either split those up by using tools such as Terraform. Yeah, and it's certainly easier to do it in the same repository compared to working over a wide range of repositories. Or if you use an environment where in which you work with multiple repositories, you may not even need stacks, okay? Because effectively, what you do, I mean, stacks in a sense that you use a technology such as TerraMate or TerraGrant, but in a sense that the infrastructure managed in those repositories might be that little, yeah, compared to what you manage in your mono repository, that the value add of introducing yet another tool is little compared to the actual CI runtime that it already has.
There's an interesting conversation in the chat. How do you manage shared resources and secrets?
Secrets are interesting. I mean, a problem in Terraform is the secrets basically end up in state. So that's why you always want to encrypt your state. The different ways of doing that, I think an easy to use way is, for example, sealed secrets, where you basically just instead of injecting an unencrypted secret, you inject an encrypted secret, right? So your state does not expose any unencrypted secrets. Or you can also use backends such as, for example, Secret Manager in AWS, Google Cloud, or Vault.
All right. Let's see, a couple last questions. There's a lot, but I don't think we're going to get to all of them. Are you using naming patterns? I'm just asking. So if yes, how do you handle block names, for example, DB names on GCP?
Yes, so we do exhaustively use naming patterns, tags, and labels. The reality is that it highly depends on your company's requirements. We usually so the easiest patterns that we use in the sense of naming is organization, business unit, environment.
Okay. Do you have plans to go towards CDK for Terraform?
Do I have plans to go towards CDK for Terraform? I believe that with TerraMate, no, we don't. When it comes to actually using CDK as Terraform, I use it exhaustively. I think it is good to reuse whatever you've put in Terraform already and basically enable developers to use it. Personally, I feel pretty comfortable with just using HCL as the syntax, and I also pretty much like a declarative approach. When it comes to moving more into that space in the sense of that we invest in our technologies, not so far, but the way that we like to take those decisions is by listening to our yet overseeable community, but hopefully growing over time. And to talk to a lot of people like you, right? To learn by looking at real world examples and problems.
Totally.
So I also gotta jump kind of in 2 minutes.
Perfect. Let's wrap it up.
Yeah.
Let's wrap it up. I think thank you so much, first of all, Zoe, for doing this. Clearly, people really enjoyed it. We still have like over 100 people hanging around, plus the people on the YouTube channel. So I'll post here, guys, in the chat the link to join the Platform Engineering Slack. Sören is there. I tagged you, Sören, on the live stream that we did. So if you guys have any questions, and I know you do because we didn't get to all of them, I just dropped them in there, and then Sören can reply and just interact directly in the Slack. So. Thank you so much again, Sören. Thank you everyone for joining us. Yeah, see you at the next one.
With pleasure, Luca. Thank you so much for giving me the opportunity, and thanks to you guys for listening. Please feel also free to give me some direct and honest feedback, especially if I can improve. Always appreciate it. Other than that, just ping me in the Platform Engineering channel. Happy to answer all kinds of questions there. Yeah, in the next couple of days. Bye bye.